Hello, class. Today we are going to be focusing on Everyday Math Lesson 6.5, a balancing act with pan balances. So here we have the monkey balancing on the rope bridge, and this is here to remind us that we have to keep everything in balance. Whatever you do to one side of the balance, you must do an equal action to the other side. Notice the arms of the monkey. When one arm goes up, then the opposite arm has to go up to keep him or her in balance. So let's take a look at how this works out in our pan balances. So here's our math message. And we have two pan balances and they're each in perfect balance. So what do we know? Well, the first thing we know is they're in perfect balance. And that means that each side is equal to the other side. So from the first pan balance, we can figure out that one cylinder is equal to two spheres because they're in balance. From the second pan balance, we can figure out that one cube is equal to one sphere. But we can figure something else out too. If we know that a cube and a sphere are equal, well, that tells us that we can substitute a cube for a sphere or a sphere for a cube. And so guess what? A cylinder will also be equal to two cubes since it's equal to two spheres. Now that we know this, we can take this information and apply it to some pan balances to see if they're in balance. So up here at the top, here's what we figured out, okay? And now we're going to use these relationships to determine which of the pan balances below are balanced. We're going to take a look at these one at a time. So let's take a look at this first one. And to see if they're balanced, I'm going to cross off things that are equal. So first, I'm going to cross off a cylinder from each side because a cylinder equals a cylinder. Well, now I don't have anything that's the same on each side, but I do have things that are equal. If you remember, up here we said a cube equals a sphere, and here I have a cube, and here I have a sphere. So I can cross off the sphere and cross off the cube. But that leaves me with a cylinder on the left and nothing left to cross out on the right. So this is not in balance. Let's take a look at our next pan balance. On the left, we have two cubes and a cylinder. And on the right, we have, four spheres. Nothing's the same, but we do have things that are equal. We know that a cube and a sphere are equal, and so we can cross off one cube and one sphere, and another cube and another sphere, because they're equal. Now I'm left with a cylinder on the left and two spheres on the right. Well, that's perfect because as we know up here, one cylinder equals two spheres. And so we can cross off a cylinder and two spheres. Everything's crossed off on both sides, so guess what? This pan balance is equal. Take a look at our third pan balance. We have a cylinder and two spheres on the left and four cubes on the right. Nothing's the same, but we do have things that are equal. So we're going to start by crossing off a sphere, which is equal to a cube. On the left, we're going to cross out our other sphere and another cube. And now we're left with a cylinder and two cubes. Well, we know that a cylinder equals two cubes. If you look back up here, we know that from before. And so when we come back down here, I can cross off the cylinder and cross off two cubes. Guess what? That means that this is in perfect balance because there's nothing unequal, nothing we can't cross out. Let's take a look at this last pan balance over here. We have a cube and two spheres and on the left-hand side, and on the right, we have a cylinder. Well, we can cross off things that are equal. A cylinder is equal to two spheres. But now we have a cube left. We don't have anything to balance it out on the other side, and so this is unequal. So let's take a look at our next set of directions. It says, for any balance that you didn't circle, add or cross out objects to balance the pans. So let's go back here. Okay, well, we have this cylinder. We could have just taken the cylinder off, but I think we're going to add some things. So what will balance a cylinder? Well, a cylinder. We could add that here. Or we could add something equal to a cylinder. So instead of a cylinder, we could add, say, two spheres. That would also make this balance. Down here, and our other balance that wasn't balanced, we had an extra cube. And we could have gotten rid of this cube, or on the other side, we could add a cube because a cube equals a cube. Or instead of a cube, we could add something that's equal. If you remember, cubes are equal to spheres. So instead of adding a cube, we could add a sphere. They would be equal, so they would be in balance. Now we're going to take this idea of being in balance and we're going to apply it to some math problems. So these are equivalent expressions. And we're going to circle each pan balance that is balanced with these expressions. Remember, an expression does not have an equal sign. It doesn't have an inequality sign. And so we're going to solve each side to see if it's balanced. Remember, balanced means equal. So if the expressions on each side have the same value, then the pans are going to be balanced. And don't forget GEMDAS. Order of operations matters here. If you do your math expression in the incorrect order, you will have the incorrect number and your pan balances will be wrong. So let's take a look at these one at a time. So here's our first pan balance. I want you to pause. Try this on your own. What does each side equal? And are they equal? All right, let's take a look at the left-hand side. We had 4 times 7 plus 2, and 4 times 7 is 28, plus 2 is 30. Over here, we have 6 times 5, and 6 times 5 is 30. And guess what? Those are equal. And so we're going to circle that pan balance. Let's take a look at the next one. So on the left, we have 3 plus the quantity 8 times 2. On the right, we have 11 plus 6. Pause. What does each side equal? Figure it out on your own. Now that you've figured out both sides, let's work together. So on the left, we have 3 plus the quantity 8 times 2. Parentheses are first in order of operations. 8 times 2 is 16. 16 plus 3 is 19. On the other side, we have 11 plus 6. Well, that's 17. And guess what? Those are not equal. So these pans are not balanced. Our next set of pans, on the left, we have 9 times 5. On the right, we have 5 times the quantity 12 minus 7. Take a minute and try this problem on your own. Pause the video. Now that you figured it out, let's check your work. Well, 9 times 5 is pretty easy. That's 45. And on the right, 5 times quantity 12 minus 7. 12 minus 7 is 5. 5 times 5 is 25. These are not equal, so we don't circle them. Here's our last pan balance. Now, you'll notice that they have the same set of numbers on each side. The only thing that's different is those parentheses. We're going to talk about that in a minute, but first, pause the video and try it on your own. Now that you've hopefully figured it out, let's take a look. Remember, parentheses tell us to do this first. And so on the left, we're going to first do 3 times 4, which is 12. So 14 minus 12 equals 2. On the other side, it says we're doing subtraction first. 14 minus 3. Well, 14 minus 3 is 11, and 11 times 4 is 44. These are definitely not equal. Now, I noticed that some of you had some trouble with this in some other math problems, and because we're talking about the associative property. Now, the associative property says that we can move our parentheses and still get the same outcome. But it only works, guys, when it's all addition problems or it's all multiplication problems. It does not work with mixed operations. So keep that in mind. All right, so for any pan balance we didn't circle, we're going to cross out expressions. So I'm going to take a look at this last one, and we're going to replace it with a new expression that'll make it balance out. So if you remember here, 14 minus 12, that equaled 2. So now I'm going to cross out this expression, and I'm going to write an expression that equals 2. Yes, you actually have to write a math problem, guys. So my math problem is going to be this: 14 minus 13, in parentheses, which means I do it first, times 2. Well, 14 minus 13 is 1, and 1 times 2 is 2. So these are going to be equal. All right, so guys, now that we've gone through our lesson, it's time to do your independent work. So guys, your independent work is to complete your student math journal, page 281, and the home link. Enter your answers in the Google form to check your work and drop into the Google Hangout with your teacher to ask questions if you're having trouble. Have a great day.